Hello everyone. In this tutorial, I will solve the study guide of chapter 2 with test prep. Question number 3 and 4, use the given graph to find the limit graphically. For this graph, question number 3, find the limit of f of x when x approach to 0. When x approach to 0, from left, f of x goes to negative 2, and from right, f of x goes to negative 2, and from left, f of x also goes to negative 2, then the limit is negative 2. Limit x, f of x when x approach to 1, when x approach to 1, from right, the function goes to negative 1, and from left, also the function goes to negative 1, then the limit is negative 1, since from left and right is the same number. Question number 4, find the limit of f of x when x approach to 2. When x approach to 2 from left, the function decreasing without bound goes to negative infinity. When x approach to 2 from right, the function increasing without bound goes to positive infinity, then the limit does not exist. Limit f of x when x approach to 0. From right, the function goes to 0. From left, also the function goes to 0. Then the limit is 0. Question number 5 to 15, find the limit if it is exists. Number 5, limit square root x plus 2 when x approach to 4. 4 is within the domain of this function, then substitute directly. Square root 4 plus 2 equals to square root 6. Number 6, limit x minus 2 over x power 2 minus 4. If we substitute directly, then we will get an undefined term. But we can analyze the denominator. Difference of 2 square, reduce x minus 2 with x minus 2, substitute every x with 2, 1 over 2 plus 2, 1 over 4. Question number 7, also 4 is not in the domain of this function. We have two methods to solve this question, either multiply by the conjugate of the numerator or analyze the denominator difference of 2 square. I use the method of analyzing, equal to limit x approach to 4 square root x minus 2 bracket square root x plus minus 2 reduce square root x minus 2 with square root x minus 2, substitute every x with 4, square root 4, 2 plus 2, 4. So the answer is 1 over 4. Question number 8, 0 is not in the domain of this function, then multiply by the conjugate of the numerator, 4 plus x, reverse sign, plus 2 over 4 plus x plus 2. Then it will be x approach 0, 4. Square root times square root, 4 plus x, 4. Square root 4 plus x times square root 4 plus x, 4 plus x. Negative times positive, negative, 2 times 2, 4 over x times square root 4 plus x plus 2 equal to negative 4 with positive 4, x with x, substitute every x with this 0, square root 4 plus 0, square root 4, 2, 2 plus 2, 4. Question number 9, 0 is not within the domain of this function, then try to unify the fractions in the numerator. The common denominator is x plus 1, 1 minus x minus 1 over x, 1, negative 1 with positive 1. Then it will be a negative x over x times x plus 1. X with x, substitute every x with 0, then negative 1 over 1 equal to negative 1. Question number 10. Negative 2 is not within the domain of this function. Then try to analyze the numerator and the denominator. X minus 2, x plus 2 for the numerator, summation of 2 cube in the denominator, x plus 2, x power 2 minus 2x plus 4. Reduce x plus 2 with x plus 2, substitute every x with negative 2, negative 2 minus 2, negative 4, negative 2 square, 4, negative 2 times negative 2, 4, plus 4, 12, equal to negative 1 over 3. Number 11, limit for x over tan x approach to pi over 4. Pi over 4 is within the domain of this function. Then substitute directly, equal to 4 times pi over 4 over tan pi over 4 equal to 4 with 4, tan pi over 4 is 1. The answer is pi. Number 12, limit x approach to negative 5 for this function. Negative 5 not within the domain. Analyze for the numerator, summation of 2 cube, x plus 5, x power 2 minus 5x plus 25 over x plus 5. X plus 5 is x plus 5, negative 2 square, 25 plus 25 plus 25, 75. Number 13, limit 1 minus cosine x over sine x, 0 when x approach to 0, 0 not in the domain of this function. Then try to simplify it. Limit x approach 0, divide the numerator and denominator by x, then limit 1 minus cosine x over x when x approach to 0 over limit, using the rule of limit, x approach 0 sine x over x equal to, this limit is 1 and this limit is 0, 0 over 1 equals 0. Question number 14, sine pi over 6 z plus delta x minus 1/2 over delta x not within delta x approach 0, 0 not within the domain of this function. So I'll use the trigonometric function sine of summation to angle a plus b equals sine a cosine b plus cosine a sine b. So the limit will be limit delta x approach 0 sine pi over 6 cosine delta x plus cosine pi over 6 sine cosine sine delta x minus 1/2 over delta x equal to limit delta x approach 0 for sine pi over 6 is 1/2 cosine delta x plus cosine pi over 6 square root 3 over 2 sine delta x minus 1/2 over delta x equal to limit delta x approach 0. Rewrite it as square root 3 over 2 sine delta x, factorize 1/2 cosine delta x with negative 1/2 plus by 1/2, it will be 1 minus cosine delta x over delta x. Then, by negative, yes, negative 1/2 plus 1/2, okay, equal to limit delta x approach 0 for square root 3 over 2 sine delta x over delta x minus limit delta x approach 0 for 1 minus cosine delta x over delta x times 1/2 equal to square root 3 over 2 is constant. I can take it outside the limit sine delta x over delta x delta x approach 0 minus 1/2 limit 1 minus cosine delta x over delta x when delta x approach 0 is 0 equal to this limit is 1, then square root 3 times 2 times 1 over 2 times 1 is square root 3 over 2 minus 0 is square root 3 over 2. Number 16, limit f of x when x approach to c is negative 3 over 4. Limit g of x when x approach to c is 2 over 3. Find the limit of f of x times g of x equal to limit f of x when x approach to c times limit g of x when x approach to c. Rules of limits, using rules of limit. Limit f of x is negative 3 over 4. Limit g of x is 2 over 3 equal to negative 1 over 2. Limit number 17, limit f of x plus 2g of x equal to limit x approach c for f of x plus 2 times limit g of x when x approach to c. Limit f of x is negative 3 over 4 plus 2 times limit g of x is 2 over 3 equal to negative 3 over 4 plus 4 over 3 equal 12 minus 9 plus 16 equal to 7 over 12. Question number 18, find the limit of absolute value x minus 3 over x minus 3 when x approach to 3 from right. Redefined x absolute value x minus 3, it is x minus 3 when x greater than or equal to 3 and negative x minus 3 when x less than 3. Since we want x approach to 3 from right when x greater than 3, then I substitute the absolute value with x minus 3 over x minus 3 when x approach to 3 from right. Reduce x minus 3 with x minus 3, then the answer is 1. Number 18, the function of greatest integer number of x minus 1 when x approach to 4. It is greatest integer for 4 minus 1 equal to greatest integer of 3 equal 3. Number 20, limits f of x when x approach to 2, where f of x is piecewise function defined like this. Since 2 is joint point, then I need to find limit when x approach to 2 from left. I'll use this segment, x minus 2 power 2 equal 2, 2 minus 2 power 2 equals 0. And from right, when x approach to 2 from right, I'll use this segment, 2 minus x equal to 2 minus 2 equals 0. Since from right and left we get the same value of limit, then the limit equal 0. Limit f of x when x approach to 1 from right for this function. When x approach to 1, it means x greater than 1. Then I'll use this segment. It will be limit x approach to 1 from right for x plus 1 equal 1 plus 1 equal 2. Question number 22. Limit f of x when x approach to 1 in general and 1 is joint point. Then I'll find limit when x approach to 1 from left. From left, when x less than 1, substitute in this segment 1 power 3, 1 plus 1, 2. And limit when x approach to 1 from right, when x greater than 1, the function is 1/2 x plus 1 equal to 1/2 times 1 plus 1, 2, equal to 1. Since the limit not from left not equal to the limit from right, then the limit does not exist. Question number 23. Find the limit of f of x when x approach to negative 2. Also, negative 2 is a joint point. Then I need to find from left. I substitute here negative 2 square minus 4 times negative 2 minus 2 equal to negative 2 square 4 times negative 4, negative times negative plus 8 minus 2. Negative 4 plus 8, 4 minus 2 equal 2. From right, negative 2 square plus 4 times negative 2 plus 6. Negative 2 square 4, 4 times negative 2, 8 plus 6, 4 minus 8 minus 4 plus 6, 2. Then the limit is 2. Since from right and left, the result was 2. Question number 24 to 32. Find point of discontinuity of the following function. F of x equals greatest integer number of x plus 3. This function has discontinuity point at all integer number and continuous at non-integer number. Question number 25. F of x equal 3x power 2 minus x minus 2 over x minus 1. This function has a point of discontinuity x equal 1, since 1 is not in the domain of this function. Let us see if the non-discontinuous is removable. We simplify the numerator, difference of 2 square, x minus 1, x plus 2 over x minus 1. Let me check. 3x power 2, negative 3x plus 2, negative x, negative 2. Then 3x plus 2. Therefore, the limit exists. Therefore, the discontinuity is removable. F of x equal to piecewise function. Check the continuity of this function as the joint point. The function defined at 2. Then let us find the limit when x approach to 2 from left. Substitute in this segment. 5 minus 2, 3. Limit x approach to 2 from right. Substitute in this segment. 2 times 2 minus 1, also 3. Since the limit from left and right is equal, therefore this function is continuous and has no point of discontinuity. Question number 27. F of 1 equals 0. Let us find the limit when x approach to 1 for this function. We already found it here. It is 3x plus 2 equal to 3 times 1, 3 plus 2, 5. Since the value of the function not equal to the limit of the function, then this function is discontinuous at x equal 1. And since the limit exists, therefore the discontinuity is removable. Question number 28. F of x equal 1 over x minus 1 square. This function is discontinuous at 1, since 1 is not in the domain of this function, and the discontinuity is not removable since the limit not exists. Question number 29. To find the discontinuity point of this function, find the domain of this function. The domain of this function is when x plus 1 over x greater than or equal 0 and x not equal to 0. Then either x plus 1 greater than or equal 0 and x less than also greater than 0, both numerator and denominator positive, or x plus 1 less than or equal 0 and x also less than 0 when numerator and denominator both negative. Negative over negative, then we get positive number. Now, x plus 1 greater than 0, it means x greater than or equal to negative 1, and x greater than 0. Let us check the intersection of these two intervals. X greater, this is 0, this is negative 1, this is 1. X greater than negative 1, x greater than 0, then the intersection is 0 to positive infinity without 0, since 0 not in this interval. For the other case, x less than or equal -1, x less than 0, intersection x less than or equal -1, x less than 0, then the intersection is -infinity to -1 with -1. These two interval is the domain from 0 to positive infinity, open interval, union -infinity to -1. This function is continuous in this interval and discontinuous. If we want to find the interval of discontinuity, let us check 0 to infinity, 0 to infinity. It is continuous here, open interval, -infinity to -1, -infinity to -1 with -1. Then the point of discontinuity of this function is -1 to 0, close from 0, open from -1. Question number 30. F of x equal to 3 over x plus 1. This function has point of discontinuity x equal -1, and the discontinuity is not removable since the limit not exist. 31. Also, this function has a point of discontinuity equal to, let us see, equal to -1 is a point of discontinuity for this function, but this point is removable since the limit when x approach to -1, x plus 1 factorized by 2, x plus 1, reduce x plus 1 with x plus 1, then the limit exists and the discontinuity is removable. Question number 32. 1 over sine f of x equal 1 over sine pi x over 2 set sine pi x over 2 equals 0. The point of discontinuity of this function should be pi x over 2 equal to n pi with pi, then x equal to n. This is the discontinuity points of this function is removable. Find the value of c such that this function has no point of discontinuity. Since the function has no point of discontinuity, then the limit when x approach to 2, the joint point from left, substitute in this segment, equal to 2 plus 3, 5, equal to the limit when x approach to 2 from right, substitute in this segment, cx plus 6 equal to 2c plus 6. Therefore, 2c plus 6 equal to 5. 2c equal to 5 minus 6, -1. c equal to -1 half. Find the value of b and c such that f of x have no point of discontinuity. First, we will rewrite this function as f of x equal to x plus 1 when x greater than 1 less than 3, x power 2 plus bx plus c. Rewrite this absolute value inequality as x minus 2 less than or equal negative 1 greater than or equal 1, and add 2 to the all sides of this inequality, then 1, negative 1 plus 2, 1 greater than or equal x, negative 2 plus 2x greater than 1 plus 2, 3. Then the inequality will be x greater than or equal 1 less than or equal 1 greater than or equal 3. Now, since the function have no point of discontinuity, then the limit x approach to 1 from left when x less than 1, the function is x power 2 plus bx plus c equal to, substitute every x with 1, 1 plus b plus c. And the limit when x approach to 1 from right, when x greater than 1, is x plus 1, 1 plus 1, 2. Then 1 plus b plus c equal to 2. And limit x approach to 3 from left when x less than 3, substitute in this segment 3 plus 1, 4, equal to the limit when x approach to 3 from right when x greater than 3, x power 2 plus bx plus c equal to 3 power 2, 9 plus 3b plus c. Then 9 plus 3b plus c equal to 4. Subtract these two equations. C with negative c, 1 minus 9 minus 8, b minus 3b minus 2b equal to 2 minus 4, negative 2. Solve this equation to find the value of b. Negative 2b equal to 8 minus 2, 6, b equal to 6 over negative 2, negative 3. Then b is negative 3. Substitute either in this equation or this equation to find the value of c. 1 minus 3 minus 2. Take it to the other side, positive 2, therefore c equal 4. Question number 35. Use intermediate value theorem to prove that the function f of x equal 2x power 3 minus 2x minus 1 has a root between 1 and 2. The function is continuous, therefore the first condition is satisfied. Then we need to find f of 1, 2 times 1 power 3 minus 2 times 1 minus 1 equal to 2 minus 2, 0 minus 1, it is less than 0. F of 2 equal to 2 times 2 power 3 minus 2 times 2 minus 1 equal to 2 power 3. 8 times 2, 16. 16 minus 5, 11 greater than 4. Since f of 1 less than 0, f of 2 greater than 0, and the function continuous, then the function has satisfied the condition of intermediate value theorem and has a root between 1 and 2. Find the vertical asymptote 36 to 39. Find the vertical asymptote for this function if it exists. Rewrite this function as x plus 2 over x. This the value x equals 0, make the denominator 0, and not make the numerator 0, then x equals 0 is a vertical asymptote for this function. F of x equals 4x over 4 minus x squared. Set 4 minus x squared equals 0. Analyze difference of 2 squared, 2 minus x, 2 plus x equals 0, x equals negative positive 2 are the vertical asymptotes for this function since this value don't make the numerator 0. Question number 38. Set x minus 10 power 2 equals 0. Square root both sides, x minus 10 equals 0, then x equals 10 is a vertical asymptote for this function since the numerator is constant. F of x equals 1 over sine pi x, set sine pi x equals 0, then pi x should be equal to n pi, pi with pi, then x equal n is integer, are the vertical asymptotes for this function. Question number 40, f of x equals tan 2x over x. Find the limit. The limit of this function is limit x approach 0, multiply by 2 and divide by 2, 2x over 2. Since this limit equal to 1, then the value of this limit is 2. This function is not continuous at 0 because 0 not in the domain of this function, but we can redefine this function as f of x equal to tan 2x over x when x not equal to 0, 2 when x equal to 0. Then the function was continuous. F of 0 is 2, limit also is 2, then the function continuous when x equals 0. See you next lesson.